Good morning, everyone. Welcome to my presentation. As you can see on the screen, our topic today is regression. Introduction. Regression is a fundamental concept in machine learning and statistics used to model the relationship between dependent variable and independent variable. The primary object of regression analysis is to be predict of the dependent variable based on the values of independent variables. Next, what is regression? Regression is a statistical approach used to analyze the relationship between dependent variable and more independent variables. The objective is to determine most suitable function that characterize the connection between these variables. This is a supervised machine learning technique used to predict the value of dependent variable for new unseen data. It models the relationship between the input features and the target variable, allowing to the estimation or prediction of numerical values. We can see the graph. Now, important terminologies: responsive variable, predictor variables, outliners, multicollinearity, underfitting, and overfitting. Response variable is primary factor to predict or understand in regression, also known as the dependent variable or target variable. Predictor variable factor is a influencing responsive variable used to predict its values, also called independent variables. Outliners. Outliners is observation of significant low and high compared to others, potentially impacting the result and best avoided. Mul- Multicollinearity, high concentration among independent variables which can complicate and ranking to influential variables. Underfitting and overfitting. Overfitting occurs when the algorithm performs well on training but poorly on testing, while underfitting indicates the poor performance of the both datasets. Now, types of regression: linear regression, multiple regression, and non-linear regression. Used to predict continuous dependency variable based on the single independent variable. Simple linear regression should use to when there is only a single independent variable. It's called linear regression. Multiple regression used to predict a continuous dependent variable based on multiple independent variable. Multiple linear regression should be used when there are multiple independent variables. Non-linear regression: relationship between the dependent variable and independent variables followed the nonlinear pattern, provide the flexibility in modeling wide range and function forms. We can see the more regression types. We can see linear regression. Linear regression is a statistical regression method is used to predict analyze. Linear regression show the linear regression relationship between independent variable and dependent variables, hence called linear regression. There is only one input variable, then such linear regression is called simple linear regression. And if there is no more than one input variable, then such linear regression called multiple linear regress. Polynomial regression. Polynomial regression is a type of regression which models the linear dataset using the linear model. Non-linear dataset using the linear model. In similar, the multiple regression, but it's with non-linear curve between the value of x and the corresponding condition value of y. In polynomial regression, the original features of the transformed into a polynomial features of given degree and then modeled using the linear model, which means the data points are best fitted using polynomial. You can see this. Decision tree regression. Decision tree is a supervised learning algorithm which can be used to solving both classification and regression problems. It can solve problems for both categorical and numerical data. Decision tree regression builds a tree-like structure in which each internal node represents the test for an attribute. Each branch represents the result of the test, and each leaf node represents the final decision or result. We can see here above image showing the example of decision tree regression. Here the model is trying to predict the choice of the person between sports car and luxury car. Characteristics of regression. Continuous target variable. Regression deal is a predicting continuous target variables that represent numerical values. Example including predicting house prices, forecasting sales figures, or estimating the patient recovery times. Error management. Regression models are involved based on their ability to minimize the error between predicted and actual values of the target variable. Common error matrices including mean absolute error, mean square error, and root mean square error. Model complexity. Regression models range from simple linear model to more complex nonlinear models. The choice of model complexity depends on the complexity of the relationship between input features and the target variable. Outfitting, overfitting, and underfitting. Regression models are susceptible and overfitting, underfitting. In interpretability, the interpretability of regression model varies depending on the algorithm used to simple linear models and highly interpretable, while more complex models may be more difficult to interpret. Pros and cons. Pros: easy to understand and interpret, robust to outliners, can handle both linear and nonlinear relationship. Cons are assume linearity, sensitive to multicollinearity, may not be suitable for highly complex. Conclusion. Regression is a cornerstone of a machine learning, providing a robust framework for predicting continuous outcomes based on more input variables. Through various techniques like linear regression, polynomial regression, and regularization method, regression models can capture complex relationships in data and deliver accurate predictions. As machine learning continues to evolve, regression remains a fundamental tool underpinning many advanced algorithms and applications. Mastery of regression technique is essential for anyone looking to excel in data science and analytics or machine learning, enabling them to be drive valuable insight and make data-driven decisions. This is the conclusion. Thank you, everyone.